All right. Sergio, let me know when we're ready.
We just started. We good?
We've been starting.
Yeah.
Log properties. Okay, so this would, I guess, be number 3. Let me start it over here. Go 3, 4, 5. So number 3 is the following. If I have log, let me do a numerical example first. So imagine I have log of 10 plus log of 20. Log of 10 plus log of 20. When I am adding 2 logs, I can combine this to be the following. Log of 200. Let me do another numerical example, then I'll write it in words. So log base 3 of 8 plus log base 3 of 9 equals log base 3 of 72. So the rule here is the following. When I am adding 2 logs of the same base, I can multiply the arguments. Let me write that down. When I am adding 2 logs of the same base, I can write 1 log and multiply. I can write 1 log and multiply the arguments. In a more variable form, this would be log of x plus log of y equals log of xy. Again, related to the exponent properties. Remember, with exponents, multiplying x cubed times x squared was x to the 5th. We added exponents. That's kind of a good way to remember this. This only works if the bases are the same. It works both ways. Like if you have this, you can break it up into this. If you have these, you can combine them into this. It works either way. Chloe. Say it one more time for me. A fraction in the beginning of the log. So I will demonstrate that with the next rule. So you mean like a 1/2 here or something? Okay, yeah. Let me demonstrate that. So rule number 4. Rule number 4. This is like the rule for logs. Like if you take like no rule away, I mean they're all super important, but like this is the one we're going to use the most frequently. And it is the following rule. Let me see how I can best set this up. So if I have log of x squared, that is the same thing as 2 log of x. So the exponent can come outside in front of the log. This gets to your question, Chloe. So, said differently, if I had 1/2 log of x, that's the same thing as log square root of x. How did I get this? Because the 1/2 comes here. So it's the same thing. Let me actually write it in 2 steps. The 1/2 comes inside, so it's log x to the 1/2, which is the same as log of 1/2. So the exponent rule yesterday was that the numerator is the power we raise it to, and the denominator is the root we take. So we take the square root of x to the 1st power. Well, we don't need to write the 1. Any number to the 1st power is itself. Another example, if I had 3 log base 8 of x, that would be log base 8 of x cubed. The 3 comes inside. Let's go Daniel, then we'll go over here.
What if there's like an exponent and an exponent?
So let's say we had 4 log 8 of x squared, then I would say, okay, the 4 needs to multiply there, log 8 of x to the 8th power. But this will almost rarely happen because we would have already brought the whole 8 outside. Javier?
So, for the fraction, what if instead of a 2, it would be like a 4 or 5?
Okay, so you're saying like this? 4 over 5?
No, like, well, yeah, it could be 4 over 5 or
Give me the
1
example.
over 5
Okay.
or
So 1 over 5 log, and I'll make it a little more complicated, of xy. You need to put it on both. So this will be log of the 5th root of xy.
So,
Lucia.
like the
Right here?
last one you did, if say like if it's xy squared, you get to multiply 5 times 2 to y separately.
Ah, yes. Let's do another example. So imagine I have 3 log of xy squared. This will be, okay, let's go log. The cube comes on both of these. Needs to come on both. So it's x cubed, y to the 6th. Y to the 6th. Lucia, I think this answers your question?
Yeah.
So the 3 is multiplied on both. 2 times 3 is 6. 3 times 1, 3. So the rule here is that the exponent comes outside in front of the log, or the number outside can become the exponent, depending on what we're trying to do. So, another example that looks like the top one is if I have log of x cubed y squared, that would be, okay, how am I going to do this? It's going to be 3 log of x plus 2 log y. I've used 2 rules here, by the way, folks. I used one rule, which I just said, which is bring the exponent outside, and then I added them because they were being multiplied. If we are multiplying, we can split them up and add. There are 2 rules that have been used here. On the common assessment, we'll give you complicated problems that have several rules for you to apply. That's where we're going with this. Did I give you any here? Not today. The next day we will. That's where we're going with this. Have to be able to apply multiple rules in one. Let me stop here and take questions on it. Let me write this in a sentence. So, if there is an exponent on the argument, the exponent can come in front of the log. So the example is if I have log of x to the p power, I'm going to bring p in front of the log. You would have to like this. Let me stop here and take any questions on Rule 4. This is the central rule. You're going to use this all the time. We're going to bring this in front of the log so many times this year. Got to know it. Yeah?
So what if there were to be a fraction in front of the log and then an exponent from the argument?
So like 1/5 and like 2.
Yeah.
Then I'd multiply 1/5 times 2 and get 2/5. So it'd be the 5th root of y squared. Yeah. Great question. Okay. Matthew?
How come it wouldn't be this 5th root of x squared and times y squared?
Because in the example I did, there was only a square on the y, not on the x.
Okay.
Yeah. I just made it up on top of my head. Good question. Okay. Let's stop this. Let me move back to the other board. Sergio, let's stop this.
Yes, we should.